process, there is a finite amount of time for that process to happen. So if a message is sent, it should be received in a specific time. If it is not received, it is as though the process has not happened. And for each process or sub process, there is a clock. It works on a clock concept. And in certain cases, you might have learned about starvation and deadlock and all, that in certain cases, if the clock does not get the reply in a specific amount of time, it means that it has not happened, something like that. Now asynchronous, there is no clock, there is no global clock. Each process is independent totally. This is more common actually. And each process, so you send a mail, I send a mail to you, it may reach one of you in 5 minutes, the other one it may take 2 days to reach. We don't know why it has happened. It is because of maybe network congestion or something like that. So likewise, one process may take a picosecond, another process may take years or a century. That is also possible. So these are the two types. Then I also told you what is communicating in a distributed system. The computers are communicating, the processes, the nodes or the computers are communicating, the processes inside the computers are or systems are communicating, the objects from object oriented programming, the objects may be communicating, components may be communicating, web services may be communicating. And how are they communicating? They are communicating through the various IPC mechanisms, inter-process communication mechanisms, like message passing. We have seen these things, sockets, multicast, broadcast thing. Then they are also communicating through other methods like remote invocation, RPC, remote procedure call, RMI, and so on. So many ways are there. Today, we are going to see a very simple concept, very little time I will take class, about a file system. Now, I know you have already learned a lot about file systems. You know files, there is a way to organize, store, retrieve, name, share, and protect files. There are many file systems that you have learned. And you are also aware that when you give a file name, say I make distributed systems class1.ppt, that file name is converted in, I put it in a directory. That to access the details in the file, this file is converted into through some sort of internal identifier. There can be a fat table or a fat index where the names are mapped to the actual location in the memory. There could be an inode and so on. And distributed systems primarily use two types of file systems. One is network file systems, or NFS, of Sun Microsystems. The other one is a good one, but it's not so popular, unfortunately. Andro file system, AFS, developed by the Carnegie Mellon University. Now, let us see each of these file systems. Now, any file system for a distributed system resides on a premise of client to server interactions. Most of the distributed systems generally have a client server interaction, and all the file systems also need to follow that. So it's very simple that the client will not only have a module which has some sort of access to the server. So primarily in all these file systems, the server will take up most of the load, most of the storage, most of the indexing. Everything happens in the server. The client only needs to be able to access at will this server, and having some sort of protocol to be able to access the files in the server. This is a long story short. Now, normally distributed systems use what is known as a flat file service, where the same system, there is each file, you may give any name. You may give distributed systems .1.xl ppt, distributed systems 2.ppt, whatever be the case. That file is mapped to a unique file identifier, and there is a table for mapping this name to the file identifier. Likewise, this UFID is like an index or an inode or an index, and that in that mapping, you give a name, it automatically goes to that area. Now, inside this flat file system, you can have a directory, you can have a hierarchy, you can map the text names to their UFID, you can have operations on the directory, you can cut a file, copy a file, concatenate a file, delete a file. Those kind of things are also possible. And primarily, there is a client module. Client module only provides the service as a single application program interface or an API from the client, from the API or the application in the client to the server. That's a very simple thing. Now, in an NFS architecture, which is very popular, if you see that primarily it is used in a Unix kernel, there is a client computer, there is a server computer. And as I mentioned, there is the server is having an NFS server also, a file server, a network files server is here. The client is connected, and at the client side, there is an NFS client. So there is a process here called the NFS server, NFS client. Client is using Word. Word is over here. Through Word or PowerPoint, it goes through this system. Through the NFS client, it communicates with the server and does the file serving or the file operations, the copying, the pasting, and so on. So this is a general simple server client. Client is generally very thin. There are not much of memory, not much of resources, and the server is having more resources, more storage. And through the client and server, files are being accessed from the server through the NFS client. There is a protocol. Now, having said that, there may be some limited storage in the client computer also. However, and there is a kind of a root structure. There is a root structure. So if you see this root, in this root, there is a client, there is a student process, staff process. These may be connected to multiple servers. A client need not be only connected to a single server. It can be connected to multiple servers. For example, here, the staff is remote mounted on the users in the server 2. Here the students are part of remote mounted on another server, server 1. So this kind of tree-like architecture is possible where a client can be connected to multiple servers also is possible in the NFS architecture. Now, in an it's a little different. Similar process only. Here the server process is called Vice. The client process is called a Venus thing. Vice and Venus are nothing but they are basically server client processes. But here in an Andro file system, there is a slight difference. Here, some sort of local copies are put in these workstations. Like, the server is very big, but this workstation need not use everything in this server. It may be using, say, only 10 or 20% of the files in the server. So those 10 or 20%, like a cache mechanism, there is some sort of duplication in each workstation. That is how the Andro file system operates. Server side, all the files are not, some amount of files are duplicated in each of these workstations or clients. They need not be the entire thing in the server, but some amount of thing is copied, and through this Venus and Vice, the interaction happens in the Andro file system. So this is not a thin client. Here it is primarily a thin client. Here it is not so thin. It may have like a caching mechanism. Some local copies are kept in the local workstation, and so on and so forth. So distributed systems primarily have these two types of file systems, namely Andro file system and network file system architecture. But generally speaking, it's a client server. The files are also in a client server relationship. Most of the files are stored in the server. Very less is stored in the client, and through some sort of client application, it connects to the server. So that's all for today from my side. I will close the class.